This is section 4.2, number 79. They want us to use a second derivative test to determine if this function has relative maxes and relative mins. So what is a second derivative test? So as a review, if I had a curve like that, the relative max obviously happens at that point. So what must be true at that point? Well, the first derivative must be equal to 0, right? That's one thing that must be true. The second, it must be concave down. So if it's concave down and the first derivative is 0, then you would have a relative max. So you would need the second derivative to be negative at that point. All this is referring to that point. And similarly, if I had a rel min, at that point the derivative would be 0, but this is concave up, so you'd have to know that the second derivative would have to be positive. If those two things are true at a point, then by the second derivative test, you have a relative min. So first we have to find where the derivative is 0. That's first. So where is the derivative 0? Let's take the derivative. I have a product rule and realize that's not x, so that's going to be a chain rule. So I leave the first alone, excuse me, and I take the derivative of the second. The derivative e to the box, I am my own grandpa, times the derivative box, which is -1, plus the derivative of the first, and leave the second alone. I look for common factors. They both have x, and they both have e to the minus x. So I will factor those out. What's left? Well, I took one of these. I still have one left. So I have an x left, and I have a -1 left. So I'm going to make that minus. And I have a 2 left. So I'm going to have a 2. Now, after I do some manipulation, I get that. What just happened? That negative moved it to the bottom. And I just rearranged the order of these two and put 2 first and minus x second. So to find or use the second derivative test, I need to find where the derivative is 0. You can't do undefined points with the second derivative test, only the derivative 0. So when is a fraction equal to 0? When the numerator is 0. So I set each factor equal to 0. I get x is 0 and x is 2. So those are my two potential relative maxes or relative mins. And the second derivative test says I find the second derivative at those places. And its sign determines if it's relative max or min. So if the second derivative is negative, that means I'm concave down. Clearly it's a rel max. If the second derivative is positive, I'm at the bottom here, it's a rel min. So therefore, I need the second derivative, and I need to find the second derivative, and I will use, what formula will I use? I guess I'll use this. And then I'll find the derivative of that. That might be the easiest, maybe. Actually, yeah, that might be the easiest. The second derivative is not going to be pretty. I'm warning you. So we have a quotient rule. So low, now when I d high, here's where it's going to get ugly. When I take the derivative of the top one, it is a product. Two things are being multiplied. So when we do d high, we have to do product rule. So d high, I leave the first alone, take the derivative of the second, plus I take the derivative of the first and leave the second alone. So I did a product rule here for d high, minus high, wow, I gotta scoot this stuff over. Minus high, which is x 2 minus x, d low, and d low I am my own grandpa, all over low squared. Woo! This is ugly. Okay, let's do this. E to the x. So in here, I'm going to simplify inside this. It's going to be minus x, distribute the 1, plus 2 minus x, minus, and then I'm going to distribute that x, 2x minus x squared, and that's all times e to the x. Okay, simplify more. This is kind of fun. Minus 2x plus 2. I have e to the x times 2x minus x. Hopefully you're all good with that. Now they both have an e to the x. I'm going to factor that out. So I'm going to be left with minus 2x plus 2 minus 2x minus x. Then I get, okay, this is minus 2x, so it's going to be minus 4x, because I have a minus 2 and a minus 2 is minus 4. Oh no. Oh no, I messed this squared up. That's a squared, right? That's a squared. Okay. I'm okay. I'm okay. So minus 2x is minus 4x. Minus a negative is plus x squared. And then I have a plus 2. I kind of put that in the wrong order because I'm a lame-o. I'll rearrange it. X squared minus 4x plus 2. Okay, I've done it. Now I'm going to plug in 0 because this says I want the second derivative at 0. So if I plug in 0, e to the 0 is 1. That's 0. That's 0. 1 times 2 is positive, so that will be positive at 0. And I plug in 2. If I plug in 2, e squared is positive. That's going to be 4 minus 8 plus 2. That's negative. So that's going to be negative. So here we go. Our final answer. We see that the derivative is 0 and the second derivative is positive, meaning concave up. So that's a rel min. So we conclude f has a relative minimum at x equals 0. You have to give a reason. Because f prime of 0 is 0 and f double prime of 0 is positive. That's my justification for relative max. That's the second derivative test. And then I would say f has a relative maximum at x equals 2. Why? Because f prime of 2 is 0 and f double prime of 2 is negative or less than 0. You could write the word is negative or the words if you wish, or you can just use symbols less than 0. So it's concave down, giving a relative max at that point. That is how to use the second derivative test.